Let us now talk about testing hypotheses about two population variances. Difference in variances is used as a measure of relative risk, like in finance, or comparison between processes, like in manufacturing. Here is the F-test for two population variances. Please note that the ratio of two sample variances follows an F distribution, and the population must be normally distributed. Suppose a machine produces metal sheets that are specified to be 22 millimeters thick. Because of the machine, the operator, the raw material, the manufacturing environment, and the other factors, there is variability in the thickness. Operators are concerned about the consistency of two machines. To test consistency, they randomly sampled 10 sheets produced by machine 1 and 12 sheets produced by machine 2. They assumed that sheet thickness is normally distributed in the population. We will now test to determine whether the variance from each sample comes from the same population variance or from different population variances. To test the hypothesis about two population variances, Step 1. Determine the null hypothesis and the alternative hypothesis. Step 2. Since the population is normally distributed, the F-test for the ratio of the variances can be used. Step 3. Let A, or the significance level, be equal to 0.05. Because we are conducting a two-tailed test, the significance level will be 0.025. We can then supply in the formula the available values like the variance and the sample sizes to get the degree of freedom numerator and the degree of freedom denominator. The critical F value for the upper tail is 3.59 and the lower tail value is computed as 5.62. The final conclusion will either be to reject the null hypothesis or to not reject the null hypothesis. That concludes our report. Thank you for listening.
Created using Powtoon.